Hello, my name is Roy Simpson. I'm an instructor of mathematics at Cosumnes River College in Sacramento, California. This is part B of a lecture for intermediate algebra on the quadratic formula. In this lecture, we're going to go ahead and use the quadratic formula to solve quadratic equations and perhaps do a couple applications. If you want to see a proof for the quadratic formula, that would be part A of this video. And part C, which is to come, will be a video on complex numbers, an introduction to them. And finally, part D will be an introduction to the discriminant. Now let's recall the quadratic formula here. Given a quadratic equation, in other words, equation of where a polynomial is involved and the degree of the polynomial is max 2, or actually just exactly a degree 2 polynomial, and it's given of the form ax squared plus bx plus c is equal to 0, where a is the coefficient of x squared, b is the coefficient of the x term, and c is the constant. If we are given a quadratic equation like that, then x, which is the solution, is given by the opposite of b plus or minus the square root of b squared minus 4ac, all being divided by 2a. Very important that that entire statement be divided by 2a. And we'll go ahead and use this in a few equations here just to test it out, test the waters, if you will. So at first we're just being asked to solve x squared plus 2x minus 15 is equal to 0. Whenever I'm asked to solve a quadratic equation, I'll ask myself first, how many terms actually have, or how many versions of x do I have? I have two different versions of x, a squared version and a normal version, a power 1 version. So this tells me that I'm going to have to rely on special techniques to solve this. Specifically, either factoring, completing the square, or now the quadratic formula. And I will often try to factor first. So let me just see if this trinomial will factor. Let's see, I know that it'll factor to x and 5 and x and 3. And let's see, it's a negative 15. And we want to end up at a positive 2. So let's try this. And I see that it actually does factor. You can test this out, redistribute, and you'll find out you get the x squared minus 3x plus 5x, and finally a negative 15. So that is true that this trinomial factors to this binomial product, which implies that either x plus 5 is equal to 0, or that x minus 3 is equal to 0. In other words, either x is equal to a negative 5 or x is equal to a positive 3. Now, that's what I highly recommend you trying to do whenever you're given a quadratic equation. Try to factor first. Notice how quick that was. It's very easy to factor that. However, I just want to show you that this could be solved using the quadratic formula as well. I'll write the quadratic formula up above. It's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. It's one of those rare moments in mathematics where you actually have to memorize something. Most things in mathematics are common sense, actually, but this, there's no common sense about it. This you have to actually memorize. So let's see here. The a term is the coefficient of x squared. So I see here that a is 1, right? Because this is 1 x squared. And the b, in this case, the coefficient of the x term, so b is 2. And c is the constant, and that is a negative 15. You always carry the sign with it. So let's plug these values in, or substitute these in for a, b, and c into the quadratic formula. So we get x is equal to the opposite of b plus or minus the square root of b being squared minus 4 times a times c, and finally all being divided by, don't forget that it's all of that is being divided by, twice a. Now you can see how bulky and horrible the quadratic formula can be if you have the better route, which is factoring. But if your trinomial doesn't factor, then the quadratic formula is the only way you can do this. So negative 2, well, it's not truly the only way. Negative 2 plus or minus the square root. I'm just simplifying, so following the order of operations, I'll go inside the square root here, and I'll take care of exponents. So this will be 4 minus 4 times 1 times a negative 15, all over 2 times 1 denominator is just 2. And again, following the order of operations here, you can hop inside those parentheses, or inside the square root, and make sure that you clean up the multiplication next. 4. Let's see, I have a negative 4 times 1 times a negative 15. That's going to be a positive 60. And again, working on the inside of those, or of that square root, I'm going to do the addition. The square root of 64. It's actually something I know offhand. Square root of 64 is just 8. So that's going to be negative 2 plus or minus 8 all over 2. Now that I happen to have it simplified down pretty much as far as I want to go, I will then write that either x is equal to a negative 2 plus 8 being divided by 2, which, by the way, negative 2 plus 8 is a positive 6 over 2, which is going to be a 3. Or x is equal to a negative 2 minus 8. So I'm taking the first part, I was taking care of the plus, now I'm taking care of the minus. All over 2. A negative 2, lose another 8, I'm at a negative 10. Divided by 2 is a negative 5. Notice I got the same solutions, x equals 3 and x equals a negative 5, but it took me a lot longer to do it. And the reason why is because, well, the shortest, fastest method is always factoring if you can do it. Let's try our hand at another example here. In this case, you have to manipulate this first a little bit to make it of the form ax squared plus bx plus c is equal to 0. Notice this format for the quadratic equation in standard form has all of our terms on the left-hand side and 0 on the right-hand side. So I'm going to go ahead and subtract 12x from both sides. Maybe I'll just quickly show that by doing this. And I'll also add 9 to both sides, but let me just first start with that subtraction of 12x here. Now I'll go ahead and add 9 to both sides. And I get a beautiful 4x squared minus 12x plus 9 is equal to 0. Now I should probably note that when you're using the quadratic formula, before jumping right into it, you want to make sure that you clean up your equation as much as possible. It's a great idea to always clean your equations prior to doing work. But what does that mean, clean equations? Well, it means if I have fractions in here, I'd like to get rid of the denominators by multiplying both sides by the LCD. If I have decimals in here, I'll probably multiply both sides by 10 or 100 to get rid of decimals. If all three of these numbers are divisible by something, in other words, if they're all divisible by 3, then I would factor a 3 out and then divide both sides by 3. Okay? So it's a great idea to simplify your work quite a bit by seeing if there's anything you can clean up. There's no common factors, there's no fractions, there's no decimals, nothing like that. Also, part of this cleaning up the equations first is moving everything to the left side, or a side. So I went ahead and wrote a few of the steps that you might want to consider prior to doing any work at all, and we've actually moved everything to one side, so we did do that bit right there. At this point, I don't see there's anything else I can do to clean this up. I might try to factor this, and it might actually factor nicely. Let's see, 4 can factor as 2x, or at least 4x squared can factor to a 2x and a 2x. And 9 can factor to a 3 and a 3. So let's see if I put minus signs in front of these. This actually might factor as well. Let's see. That's 4x squared. And then 2x times a negative 3 is a negative 6x. And then negative 3 times 2x is another negative 6x. And finally, negative 3 times the negative 3 is actually a positive 9. Combine like terms, and you do get that this was the proper factorization. So again, I easily have a factorization here, and I shouldn't use the quadratic formula. In fact, a lot of people write this as 2x minus 3 quantity squared. But again, let's get some practice with the quadratic formula. Since I happen to know that the only thing that will make this equation 0 is if 2x minus 3 is 0, or in other words, that x is equal to 3 halves. So I know the solution should be 3 halves. Interesting as it may seem, this actually looks like it has only one solution. Technically, there are two solutions. They're just the same two solutions. X equals 3 halves from this first factor, and another x equals 3 halves from the second factor. So let's solve this using quadratic formula. Remember the quadratic formula, negative b plus or minus square root b squared minus 4ac, all being divided by 2a. In this case, again, I'll just look back to, let me highlight it. I'll look back to this equation right there. 4 is playing the role of a, negative 12 is playing the role of b, and positive 9 is playing the role of c. So that means that x is equal to the opposite of b, which is going to be now a positive 12, plus or minus the square root of b squared minus 4 times a times c, all divided by twice the value of a. Now I took my time in the last example for PEMDAS, showing the order of operations. Now I'll just speed up a little bit. Let's see, that's 144. And we have, what is that, 36 times 4. So that would be a negative 144 actually. All being divided by 8. Oh, well, underneath the square root, that's just 0. So that's 12 plus or minus 0 all over 8, or in other words, 12/8. Notice the plus or minus disappears, so we only have one answer. And this reduces down. Whenever you have a fraction in mathematics, especially at this level, everything that you've learned up to this point in mathematics is fair game. You need to use everything you've learned. So always reduce fractions. Anytime you have a fraction that you don't reduce is cause for point loss. So this would be 3 halves. There we go. Which is exactly what we said it would be if we had just factored in the first place. I want to draw your attention to the fact that we have these two. I said we have two solutions, so maybe I should say this is a repeated solution. It's really, some people call them repeated roots or repeated solutions. So just to let you know that if you have a solution that occurs twice, like in this case we have two occurrences of x equals 3 halves, one from this first factor and one from the second factor, we would call that a repeated solution or a repeated root. And the idea of a root we'll introduce later on in a future lecture, but just to let you know, we'll get the language out there now. Our last basic practice problem for this, we're just going to go ahead and solve a quadratic equation that involves some fractions here. And again, recall what I mentioned earlier, that we always clean equations first. So that means move everything to one side, which is already done, clear fractions, and factor out any common factors. In this case, I see there's fractions throughout, so I'm going to find the LCD, and it turns out the least common denominator of this entire equation. Let's see, we have a 3, we have a 2. The LCD is going to be a 6. It's one of those nasty little facts in mathematics that instructors often have you find the LCD, which technically is not necessary. You could actually find any number that both of those denominators divide into. So it doesn't need to be a 6, it could be a 600. The problem with it, with the 600, is that you end up with very large numbers, so it's a little counterproductive. Alright, now what I'm going to do with that LCD is multiply both sides by it. So I'll grab the left hand side and multiply it by 6. I'll grab the right hand side and multiply that by 6. Remember, it's an equation, so you're allowed to multiply both sides by the same number. Following the laws of distribution, I'll distribute that 6 on the left hand side to each of the items within the parentheses. That's the idea of distribution. So I have 6/3 x squared plus 6x plus 6/2. The right hand side is 6 times 0 is still 0. That's the beauty of multiplying 0 by anything. And of course, this equation reduces down, or the coefficients do, to become 2x squared plus 6x plus 3 equals 0. I should probably keep my implication signs in there so that you know that the last step implies this next step, and so on and so forth. Again, when I see this, I'm going to go ahead and try to factor. I know to factor 2x squared, I'll need a 2x and an x. And to factor that 3, either it's 3 times 1 or 1 times 3. Let's see, 2 times that 1 would be 2x, and 3 times this x would be a 3x. Well, there's no way I can combine a 2x and a 3x to get me to 6x. And along the same lines, 2x times that 3 would give me 6x, and we'd have an extra 1x. There's no way I can combine those two to get me to 6x. So this does not factor. This is what we call a prime polynomial. And since it's prime, the only way that you can, prime meaning that it doesn't factor, since it doesn't factor across the integers, we now must go ahead and rely on other methods to solve this. And our next best method would be the quadratic formula. So let's go ahead and use that. Notice in this case the role of A is being played by 2, and the role of B is being played by the number 6, and the role of C is being played by the number 3. So the quadratic formula is going to be x is equal to the opposite of the B term plus or minus the square root of that B term being squared minus 4 times the A term times the C term. And I'm using these words term, really in reality they're not terms, they're just A, B's, and C's, but all being divided by 2 times the value of A. Now this has to be simplified quite a bit, so we'll go ahead and do that. That's negative 6 plus or minus the square root of 36. Let's see, that's 6 times 4, that's a negative 24, all over 4. This becomes a negative 6 plus or minus the square root of 12, all divided by 4. And at this point, I'm going to mention something as an aside. If you're in a course where you've covered radicals already and reduction of radicals, then you know that this radical right here can be reduced. However, if you have not covered that topic in your course, then your instructor might not require you to reduce this radical, and this would be a perfectly fine answer. So it just depends. If you have not seen reduction of radicals in your course yet, then technically this would be considered done, and you're okay. However, the next little bit is for those who have instructors that that have shown how to reduce a radical, or perhaps that you know how to do that from a previous course. And actually, before I continue on, I want to actually write my answers as x equals a negative 6 minus the square root of 12, all being divided by 4, and x equals a negative 6 plus the square root of 12 divided by 4. Something important to note here, the negative 6 minus the square root of 12 over 4 is the smaller answer. The larger answer is the negative 6 plus the square root of 12 over 4. That's the more positive answer. Now, for those who have done reduction, you know that the square root of 12 is the same thing as the square root of 4 times 3, which is the same thing as the square root of 4 times the square root of 3, and now you know the square root of 4 is just 2. So, in your case, your answer would be negative 6 plus or minus, instead of the root 12, it would be 2 root 3, all being divided by 4. And then you would look at this fraction and notice the numerator, those two terms in the numerator have something in common, a 2. So I'll factor out a 2 of a negative 3 plus or minus root 3 all over 4. And I see that 2 goes in the 4 twice. So this final answer would actually be just 1 times this numerator, or in other words, just the numerator, all over 2. So there are your two possible answers. Negative 3 plus square root of 3 over 2, and negative 3 minus a square root of 3 all over 2. Both answers are sufficiently correct. Now let's try our hand at something that's generally thought of as a more difficult or challenging problem. Solving x squared minus 2xy plus y equals 10 for x. Now, something you should note, in this case we're assuming that our only variable is x. So just remember that's the only variable in our problem. Technically it's not the only variable, but for our case we're going to pretend as though it's the only variable. So recall what I said earlier, which was this little list of items I'm going to go ahead and write down here. Always clean equations first. So that means move everything to one side, clear fractions or decimals, and factor out any common factors. In this case, I can at least subtract 10 from both sides. So I get this x squared minus 2xy plus y minus 10 is equal to 0. And now I'm going to have to think about, if x is the variable, and I want to write this in quadratic equation form, which is ax squared plus bx plus c is equal to 0, I'm going to have to figure out what the coefficient of x squared is. Well, there's just a 1 hanging out in front of that x squared, plus something times x plus something else is equal to 0. This is how I would probably set this up. The junk hanging out in front of x here is actually a negative 2 and a y. And if you don't believe me, take a look at that term right here. You see it's a negative 2xy, and now look at the term that I just wrote here. It's a negative 2 times x times y. I just wrote it in a different order and used the multiplicative property of association. So in other words, I associated the negative 2 and the y together. Finally, the rest of the stuff that doesn't have x's attached to it, I'll write in this last parenthesis, and that would be that y minus 10. Now, that's a pretty tough thing. A lot of people don't see that, but the fact is what you're looking for are things that are attached to x squareds, things that are attached to x, and then things that are not attached to any type of variable x at all. And now I'll go ahead and write out what a, b, and c are. A is just 1, b is just that negative 2y, and c is just the stuff in this parentheses, the y minus 10. So let's go ahead and use a quadratic formula here. It tells me that x is equal to the opposite of a, which is actually going to be 2y, plus or minus the square root. Did I say a? I meant the opposite of b. The opposite of b, which is 2y, plus or minus b squared supposed to be a square there, minus 4 times a times c. And this whole thing is going to be divided by twice a. So let's go ahead and clean this up. Very important that you know how to clean all this stuff up. Use all your skills from previous courses. Let's see, negative 2y being squared is a 4y squared. And then I'm going to just distribute this negative 4 into this y minus 10. So I'll get a negative 4y plus 40. And this is all being divided by 2. Now, I would like to see if maybe that trinomial factors. It might not, but it would be interesting to see if it did, just out of curiosity. So technically, I'm hoping I'm done, but I'm just going to go ahead and maybe see if I can go any further with this. So let's see, x is equal to 2y plus or minus, because you should always ask yourself if you can simplify further. One thing I see that each of these terms in this trinomial underneath the square root, they have in common is a 4. So I'll factor 4 out, and I'm left with a y squared minus y plus 10, all being divided by 2. And now, inside this square root, that's just an object, 4, times another object, and I'll highlight that, y squared minus y plus 10. It's just two objects being multiplied. So you can break that square root up. That's x equals 2y plus or minus the square root of 4 times the square root of whatever's left here, y squared minus y plus 10. And this is all being divided by, again, 2. What's interesting about this is that square root of 4, that just turns into the number 2 as well. In fact, since I've already made a mess here, I'm just going to continue with this. Let me erase all this. So this is equal to 2y plus or minus 2 times the square root y squared minus y plus 10, all divided by 2. In this case, I could factor both the terms up top. There's two terms. One involves a 2 and a y. The other one involves a 2 and the square root of some junk. But both those terms have a 2 in common. I can factor that out front. I would be left with a y plus or minus the square root of that junk. And this is all being divided by 2. And now you can see it. It's 2 times some number divided by 2. That 2 over 2 will cancel nicely. They're common factors. And so we get this final answer. Y plus or minus the square root of y squared minus y plus 10. You might want to see if that factors that y squared minus y plus 10, but it actually doesn't, so I'm just going to leave it alone. That's more advanced. That's super advanced if we did that. A pretty interesting example. Rewind it, watch a few times to see if you could get it. Now let's go ahead and do maybe a couple applications here. This is one of my favorite applications. You also see this in textbooks quite often. This is a fencing problem. Sometimes you have them up against a barn, you have them up against rivers. Sometimes you have several enclosures. That's this case right here. So let's go ahead and talk about it. And what you should always do whenever you see a problem that I'm doing, you should pause it and try it by yourself first. But a dog trainer has 100 meters of chain link fence. She wants to enclose 250 square meters in 3 pens of equal size. Now, I have several instructions here. I know that I'm going to write an equation about the amount of chain link fence. I'm going to solve for L in terms of W, write and solve an equation for W for the total area enclosed, and find the dimension of each pen. Essentially, what they're really asking for is for me to find the dimension of each pen. Now remember, there's this tactic for doing all word problems. You always read them first, of course. you understand the situation, and usually in this step here you want to maybe draw a picture. So let's go ahead and just draw a picture of this situation. So I have some chain link fence, and it doesn't say it, but I'm assuming we're going to make a rectangular pen. Okay. She wants to enclose 250 square meters in 3 pens of equal size. So here's 1, 2, 3 pens. They're all of equal size, and everything in blue here, besides the numbers, is the chain link fence I'm using to build this. Okay, so that helps out with my visualization. The next thing I need to do is label the unknowns. And in this step, it's always important to use the word let. So I'm going to say, let's see what we're trying to find. Find the dimension of each pen. Okay, so let W equal width of each pen, or I'll just say a pen, and L equal length, because that's what we're being asked to find, length and width. Very important step there to label. So maybe I'll even draw those on the picture. Let's call this the width. So therefore this must be the width, this must be the width, that must be the width. And this is the length, so this must be a length, this must be a length, this must be a length, that must be a length, that must be a length. They're all the same size pens, so that's why I know those L's are all the same. The next thing you do after you're done labeling the unknowns is to write equations, and this is the hardest part usually. You want to write equations relating these variables. If you have 2 variables, you need 2 equations. If you have 10 variables, you need 10 equations. Well, in this case, a dog trainer has 100 meters of chain link. That means that all this fencing being used adds up to 100. In other words, these 4 sets of W's plus these 1, 2, 3, 4, 5, 6 sets of L's must equal 100 feet. The other thing that we're told is that the area, the total area, is going to be 250. And remember, the area of a rectangle is length times width. Well, the width of this rectangle is W. But the length is actually 3 of these L's. Okay? So now I see I have 2 equations with 2 unknowns. Now let me show you a little trick here. You generally pick an equation and solve it for a variable. And I like to pick the equation that doesn't have letters multiplying or variables multiplying each other. I like to pick this top equation and solve it for a variable. I'm going to solve this top equation for L, sort of. So I have 6L is equal to 100 minus 4W. That's just me subtracting 4W from both sides. And I'm going to have you notice something very important here. I could solve for L, right? I could divide both sides by 6 right at this point. That's absolutely fine. But notice something here. Do I want to really solve for L, or would it be better for me to solve not for L, but for 3L? It turns out that solving, I mean, you can solve for L, you'll just get fractions. And if I want to avoid fractions here, I'm just going to divide everything by 2 instead. So watch my actions. I'm going to divide both sides of this equation by 2. That means divide each object by 2. And I'll get the following. I have 3L is equal to 50. Oops, not 500, 50. Minus 2W. So any place that I see a 3L, I'm going to replace it with 50 minus 2W. So there's a 3L right there. I'm going to replace that 3L with 50 minus 2W. It's a little tactic. I mean, the fact is you could have divided both sides by 6 and solved for L and substitute that in for L and multiplied that result by 3. You would have gotten the same thing. It's just it's a neat little tactic. If you notice that you have a 3L, not just an L, then solve for 3L instead of just L. Now, at this point, I see I have an equation. So I get to a point where once I've written my equations, I forget about the word problem and I just try to solve that system or that set of equations. So I forget about the word problem at this point. I just look at this equation right here, and I'm going to distribute this W through to get 250 is equal to 50W minus 2W squared. And I see right now it is going to be a quadratic equation. I just have to do what I've been saying the entire time, which is clean up this equation first. Move everything to one side. And I'm going to choose to move everything to the left side. The reason why is that if I move everything to the left side, my coefficient on W squared here will be a positive 2. So I'm going to go ahead and move everything to the left, so I'll have a 2W squared minus 50W plus 250 is equal to 0. And remember also, part of my clean up the equation step here is not only just move everything to one side, but clear fractions, clear any type of decimals. Also, factor out anything all three of these terms have in common. And if you look at all three of these terms, they're all divisible by 2. So I'm going to factor a 2 out of all of these. Let's go and do it down here. I'm left with W squared minus 25W plus 125. And that's equal to 0. And in fact, I could divide both sides by 2 now so that I get the following. W squared minus 25W plus 125 is equal to 0. I'll try to factor this if I can, but if I cannot factor this, then I'll go ahead and use a quadratic formula. And actually, this does not factor nicely because the only way I'm getting two numbers to multiply to 125 is either 5 times 25 or 1 times 125. So, and there's no way I can combine either of those to get to a negative 25. So this I'm going to have to solve using quadratic formula. Quadratic formula says that W is equal to the opposite of the coefficient on W. So in other words, a positive 25 plus or minus the square root of that B term squared minus 4A, and then C term here is 125. This is all being divided by 2A. Some people might be wondering, well, what if I didn't factor out that 2 and I just did the quadratic formula on this step right here? You would get the same answer. You just have a lot more simplification to do in the end. But it's totally okay. Anyway, this turns into negative 25 squared is that 625. And then negative 4 times 125 is going to be a negative 400, negative 500. It's all being divided by 2. So that's the square root of 125 actually. So W is going to equal 25 plus or minus the square root of 125 all over 2. Now, because I don't know if your instructor will have you write things in exact form, I probably would suggest it initially. But it's important also to be able to approximate fractions. So let me write this on a different page so that we have the widths here nice and clean. So this is 25 plus or minus the square root of 125, all being divided by 2. And if you want to simplify this, you can tell that 125 is the same thing as 25 times 5. And that the square root of 25 times 5 can be broken up. And again, if your instructor hasn't talked about breaking radicals like this yet, then don't bother. It's totally okay. You can leave your answer like this. It's totally fine. I'm just taking precautions just in case somebody else has an instructor that's gone through this. Square root of 25 is 5, root 5 all over 2. We really gain very little by doing that, by the way. In application problems specifically, it's very, 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 well, it's not very worthwhile, let's just say that, to do something like continually reducing once you get to an answer. Because in application problems, I'm likely to ask something like, well, what are the widths? What are the widths of these pens? I mean, one of the widths could be 25 plus 5 root 5 over 2. And one of the widths could be 25 minus 5 root 5 over 2. Or if you didn't simplify, 25 plus root 125, all being divided by 2, and 25 minus square root of 125, all being divided by 2. At this point, I would just grab a calculator because that's the only way that I can get a good answer for either of these. So, little graphing calculator lesson here. If you're going to do this all in one fell swoop, because your numerator has several operations going on, start a parenthesis for your numerator here and type in 25 plus 5, and the square root is in yellow right above the x squared, so to access that you hit the second. You can see the up arrow for the second. Then the square root of 5. When you hit the square root button on at least on a TI graphing calculator, it starts a parenthesis for you. So you're going to have to close that parenthesis to close out the square root. And then you're going to have to write another close parenthesis to close out the numerator. I'm going to divide that entire numerator by the number 2. And here's what I get for this width, and I'll round it to the nearest tenth. So this width is roughly equal to 18.1. In the other case, I'll write a roughly equal to here. Let me go ahead and recall what I've just typed. So let me hit second, and I'm going to hit the enter button because that gives me my last entry. And scroll back here, and where my cursor is, I'm just going to hit the minus sign, so it changes it to the minus, and hit enter. 6.9. I'll move this off the screen because I'm interested in knowing the units here. We have meters. Okay, so we're talking about meters of chain link fence. So the width in this case would be meters, and the width over here is also in meters. Now, the original question was asking us to find the dimensions of each pen, so that means we need the length and the width. And there's a relationship between length and width. We know that the length, 3 times the length, is 50 minus 2w. So I happen to know that 3 times the length is 50 minus 2w. Or in other words, dividing by 3, the length is just 50 over 3 minus 2/3 w. So I can substitute these values of w that I have here in for the w in this equation to find out the lengths, the corresponding lengths. So let me go ahead and say this implies the length is roughly equal to, and this one implies the length is roughly equal to, and we'll plug it into this equation. Let me go back here. Let's back up. So we had 50/3 minus 2/3 times w. Now, we have 2 different versions of w. One of them is 18.09016994, and I would highly recommend using as many digits as possible. When you're doing approximations, it's great to use the exact value. In fact, you sometimes can use second answer to use the last number that the calculator got. So this one will actually calculate the length for the fencing when the width is 6.9 meters. So that'll be 12.06, or in other words 12.1 if I round to the nearest tenth. The other one So the second entry. I'll replace the word answer with 18.090169994. Hit enter. 4.6 meters. So there's two possibilities for the setup here. Scroll this off. There's two possibilities for setup to get to this situation that we're asking for here. If we have 100 meters of chain link fence and we want to enclose 250 square meters in 3 pens of equal size, we can make two configurations, either 18 by 4.5 or 7 by 12s for pens. Now notice there are other things here in this question, like write an equation about the amount of chain link fence. That's this one right here. Solve for L in terms of W. That's what we kind of did here. Write and solve an equation for L for the total area. That's what this is here, and that's what this is there. And find the dimensions of each pen. So essentially, parts A, B, and C are me just walking you through how to do it. But honestly, if you follow the problem-solving process here, you'll be fine. Just remember, keep your goal in mind that you want to find the dimensions of each pen. As a final example here, we'll just take a look at if the legs of a right triangle are x and x plus 1 and the hypotenuse is 2x minus 1, find x. So let's draw this picture. I've read the problem, I understand what's going on, and in fact I'll go ahead and draw a picture to help me understand what's going on. So here's a right triangle. They've given me the labels that I'm going to use for my legs here. This is x, this is x plus 1. Those are the legs. The hypotenuse is the side opposite the 90 degree. We call this 2x minus 1. And we just want to find x. In this case, there's a way to relate all three sides here. So you're always looking out for a way to relate your variables. In this case, the relationship is given by the Pythagorean theorem. And if you need help on the Pythagorean theorem, just go ahead and Google that, and you'll be able to figure that out. But essentially, it's just leg squared plus the other leg squared should equal the hypotenuse squared. So let's go ahead and do this. We're going to simplify this equation. This is x squared plus, this is x plus 1 times x plus 1. That's what x plus 1 squared is. And then 2x minus 1 being squared is 2x minus 1 times 2x minus 1. Starting with the distribution process, this will be x squared plus 2x plus 1. You could pause it and verify that if you want. The other one will be 4x squared minus 4x plus 1. Whoops. There we go. 4x squared minus 4x plus 1. I will move, well, let me combine like terms on each side. So let's see, that's a 2x squared plus 2x plus 1 equals a 4x squared minus 4x plus 1. And now, choose a side to move things to. I'm going to move everything to the right-hand side to keep my variables positive, the coefficient on my x squared term specifically. So I'll subtract 2x squared from both sides, so I'll get a 2x squared. I'll subtract 2x from both sides. And I'll subtract 1 from both sides, which leaves me with no constant. And now I get to solve this. Now, don't just jump into using the Pythagorean theorem here. Or not Pythagorean theorem, I'm sorry, the quadratic formula. Don't jump into using quadratic formula. The fact is, always ask yourself, can I clean this up? Is there something I can factor out of both these terms? Sure. You can factor a 2 and an x out of both of them. And if you do that, you're left with x minus 3. Now look at this. This is the zero factor property or well, whatever, zero factor principle. It just depends on your textbook. But it essentially says that you have two objects multiplying to equal 0. So that means either the first object is 0 or the second object is 0. In other words, either x is 0 or x is 3. Now start checking this for realism, because whenever you're dealing with an application, you should always check for realism. If x were 0, then this length here would be 0. That doesn't make sense, so that's not realistic. That's what we call an extraneous solution in this situation. If x were 3, well, it's okay for this length to be of length 3. It's okay for this to be even more than 3. And 3 times 2 minus 1 would be 5, so that's absolutely fine, I guess, for this as well. As long as they're not negative values, we're cool. So that will be the solution.